Hello, this is Greg Allison from Galactic Greg's coming to you from an undisclosed location somewhere in the Milky Way galaxy. And today we're going to talk about Elon Musk, SpaceX, analysis of risk and opportunities, risk and strengths of the Starship program. And I got to start with the risk side, and then we're going to talk about the strengths that SpaceX faces. And on the risk side, we're going to look at initially the safety risk and the programmatic risk. And from the safety risk side, we're going to look at flight risk, and then we're going to look at ground risk. And so we'll start this back with a reminder of Allison's laws of rockets. And I derived these laws of rockets some 20 odd years ago when I was launching hybrid rockets from high altitude balloons. I come to the fast realization that, and I figured that if Norm Augustine could have his laws, I could have mine. And my laws are as follows. 1, rockets go boom. 2, rockets have always gone boom. And 3, rockets always will go boom. And the reason I have these laws is to put in perspective what it means to fly on a rocket. You know, that sounds, Greg, that sounds silly. What is all that about? It's about this. In a rocket, you have a lot of parts, a lot of pieces, and it's like a long chain of links all linked together, every one of which has to work perfectly. In a rocket, everything has to work, almost. You've got to have a million things go right to have a successful flight, but just one thing to go wrong could spell catastrophe. And quite often, you will find in space flights failures are when the holes in the Swiss cheese line. Maybe you have redundancy and things that are designed to give you safety to keep bad things from happening. But sometimes the holes in the Swiss cheese do line up and the bad situation, the risk gets through. You got to look at all that. But the key thing about a rocket is you ascend on a controlled explosion. You ride on an explosion. And when you go into orbital velocities, you're coming back like a meteorite. And every step in between, none of it is trivial. You're using typically, quite often, highly explosive, cryogenic, very cold fuels being fired through into very hot engines. You have vibrations, you have structural stresses. You're going into the vacuum of space. In space, you are being roasted on one side, frozen on the other side. You're in a high radiation environment. You're in a vacuum, and you have to put so much energy into your body or all the systems of the vehicle. It's like TNT in every cubic centimeter, quite a bit of it. So you have to put all that energy in and then take it back out safely. Rocketry will never be as safe as airplane flight in commercial airlines. That doesn't mean we can't make it relatively safe, but you have to understand there are risks associated. And that's why I came up with this notion of Allison's laws of rockets. It sounds simplistic, but it will always be true that rockets go boom, rockets have always gone boom, and rockets always will go boom. Excuse me, do my left hand, that's what I should be using. All right, I've belabored that point maybe a bit too much, so we'll move on and talk about the very nature of some of the safety threats for flight systems in a rocket. We all are aware of things like, well, SpaceX, for example, has a lot of engines on their boosters now, a lot more. And bear in mind that as parts count goes up, reliability goes down. Typically, there is an exception to that, somewhat we call it redundant systems. And that's especially applicable to avionics and hydraulics and things like that. So parts count goes up, reliability goes down. Now think about it. If you got several engines on the stage, if one engine blows up, it can take out multiple or even all of the engines on that stage and other structural elements of the booster. So you do not want an engine to detonate, but every time you have a different engine, you have potential for detonation multiplied. And one of the things you've got to bear in mind is what the Russians found in one program was it had so many engines they couldn't manage the acoustics of the system. And one of the principal acoustic problems is something we call pogo with an engine being launched. And pogo, what happens is on ascent, vertically as you're going up, you're as you accelerate, the fuel surges down into the engine, and what happens then is you accelerate even more because you get more pressure in the engine. Well, that also causes back pressure on the fuel additional fuel trying to come in, which causes the engine thrust to die off a little bit, but then the next thrust, you get a cycle feeding on itself of an oscillation of thrust going up and down, and your vehicle starts having a force on it that's kind of like this. That's why they call it pogo. It's like jumping on a pogo stick. And it literally don't quite look like that, but it's close enough. And you can structurally tear your vehicle apart, especially if you have a vibration in the system that's resonant with the structure of the vehicle or some primary component of your vehicle structure. They found this in the Titan program when we're doing Gemini. They found it in Apollo 8 when they thought they had all this solved. And what they found was that the F1 engine was actually the S1C first stage of the Saturn V was resonant at a point in flight when the fuel had depleted so much in the S1C stage. Not across the entire spectrum, just at one point in flight, and that's all it took. And that resonance caused problems, severe problems. Apollo 8, they thought they had all that solved. So what they did is they came up with some type of partial gas accumulator in the inlet feed in the fuel tank to try to solve that. Actually, the accumulator, for the Saturn V was it was helium gas going into the pre-valves. I believe it was the LOX pre-valves in the engine, pre-valves in the engine. The accumulator was actually used in the space shuttle system. So they've always had to come up with various means to control pogo. Pogo is just one of many things that can go wrong. You got to remember, all your components are under high stress because you need low weight components, because mass fraction, having as much little mass in the vehicle and as much mass for fuel as you can get, is what you need with a vehicle. It's got to be able to withstand great pressures, have very low weight, and an airplane, you put in what we call design margin. You make the walls thicker to give you extra strength, to give you extra margin. You still try to have margin in a space system, but you try to skinny it down for performance. And you require a lot of performance because the rocket equation is not a very forgiving thing, especially if you're returning stages back to the ground and you have to carry extra fuel to do that. That's fuel that could have been payload. It cuts into your performance. You normally trade a little bit out of structures, or you try to make up with it by building larger boosters. And well, the Starship system seems to be destined to do that. So that is, there's many ways to look at these things and try to manage them, but that's just on the propulsion system, the feed system. You can have all kind of problems with valving, valves that don't open in the right order, sensors that fail, and sensors can fail and give you the wrong readings, false positives, false negatives, based on the fact that they're being vibrated, shoved loose, they're too hot, they're too cold. The wire breaks because the whole system's under acceleration. If you don't have all the wire tied in real good, where it's nice and sound, where there's no structural strain upon them. If the bend radiuses aren't too much, if you don't have cracked insulation, it lets electrical current establish into the structure of the vehicle, giving you a short to ground or an EMI susceptibility or a radiated emission that's going to cause a problem in another system. And I'm just getting started. So as you see, there's quite a few technical challenges to any rocket. Oh, great. Well, SpaceX has been doing this and they're getting good. Yeah, but Starship is a new system, very new and radically different design. And the technology readiness level of this, which is the maturity of the technology, is not particularly high, and we're accelerating the launches. However, the test program of SpaceX hopefully will alleviate that. So, we'll talk about these things, pogo, and another thing in your vehicle is your GNC, guidance, navigation, and control. Like I've mentioned before, when you're on a rocket, and you're trying to do guidance, navigation, control, you're trying to take that rocket where you want it to go. Well, it's all done from the bottom down here where the engines are. And it's kind of like trying to balance a pencil on the end of your finger, but you really got to make it go in the right direction. And typically those engines, I dropped my rocket here. Typically those engines on a gimbal just a few degrees, and you don't want too much dither or you'll overcompensate and throw it. And so they've got to be very sensitive. Now, the fact that SpaceX has proven that they can land on the deck of a heaving barge shows they probably got that well under control, but there always is potential that something can go wrong to drive that system out. Any one of the avionics boxes that contribute to this system, the communications systems between them, the data buses, the power buses, if any of these go awry, if there's a failure or a problem, you could have a severe consequence. And talking about power systems, we know that Elon Musk is fond of using lithium-ion batteries. And I could do a whole video on lithium-ion batteries because lithium-ion battery can have thermal runaway in any individual cell. A lithium-ion battery cell just sitting on a counter could go into thermal runaway due to growth of dendrites within the system, or FOD, or some accumulated problem in the separator membrane that runs through the cells, allowing a current to get established to short between the anode and the cathode, which would cause heating in the system, or externally applied heat and external short. Any of these, so internal shorts, external shorts, any of these things can lead to thermal runaway. And there's enough oxidizer in the cathode of a lithium-ion battery, typically to burn 15% of the electrolyte inside of it. And when it burns, it shoots out a flame like a little solid rocket motor. Great, we'll have them in vacuum, they won't burn. Oh, they got the oxidizer inside. And you can have self-propagation where one battery goes to another, and you can have a really big fire. Now, there are methods to control those hazards. And like I said, I will go into that. I'll do a video on that one day on just battery safety and how some future research could lead to safer batteries. But that is an area of risk. There's quite a few things, as I mentioned, that could go wrong. We are putting more and more of these lithium-ion batteries in systems. For example, in MK1, and I believe the MK2 and probably subsequent vehicles, Elon Musk is looking at having his fins actuated by electrical systems driven by lithium-ion batteries. Now, of course, he puts a lot of these in his Tesla cars running around, but mind you, it is a different thing to run around on the ground as opposed to, flying in the shaking environment of a launch system, where you have the shaking, the heat, the cold, and all that. It is a different environment. And the battery safety numbers that I would use are based on naval battery safety, where they've aggressively pre-screened systems and batteries, and they're used in the flights of military aircraft. That's what I will use over in the future. So it is a real concern. So you got guidance navigation control, your flight computers, your sensors that tell you what you're doing and how well you're doing it. The software that plays a big part in GNC, also controlling your systems, the TVC that's the actuator that's been driven by your GNC, guidance navigation and control. And then you have just your structures. I mean, from the structural elements of your vehicle to the flaps, all the aero control surfaces, if something gets stuck. I remember one time there was an airplane crash because a screw in the rudder caused it, got a to come out or something. And it was an Air Alaska flight that went down in the Pacific Ocean. And these planes have been flown for a long time. This was a failure mode that no one even had a thought of. So we try to think about failure modes of systems, and sometimes there are ones that we don't think of that take years to manifest. So you never necessarily ever discover all the failure modes, especially in a vehicle that's not used for millions and millions of flight hours, which I suspect will be a long time before we get there with these rockets. All that said, that is some of the key areas in flight that you really have to worry about. Is when you're doing transitions. For example, let me find another pen here. We're flying, Starship and Super Heavy and in a form of a BFR. When you staging is an event. In events, you could have pyrotechnics associated. You could have tip-offs as you go from one to the other. You could have recontact. There's many things that can go wrong in staging. But once you get free, if you're flying and then you get on orbit, then you got another problem. You're bringing up the refueling booster. So you have another event where you're getting together and you've got a rendezvous. Then you got to depart. Well, you're transferring fuel too. That's also risky. And then when you're coming back down and you're flying in this belly flop configuration, coming in like a meteor, you are at some point going to reach the ground. You got to do a transition and like that, and then land. Every phase change is a great opportunity for things to go wrong. And so a whole lot of your failures take place in phase changes, and a lot of risk analysis do not equate those in equal weight, especially some of the probability things I've seen using Bayesian analysis. I won't go into that. But anyway, needless to say, these are potential failure points in flight systems. But I would say that, you know, if I were Elon, I would be as much, if not more, worried about ground safety. In fact, I would be worried about, say, you know, you got to worry about safety of your facilities, your crew on the ground, but also you've got to be concerned about safety to the communities nearby. And as I mentioned in a previous video, when the Russian N-1 booster blew up on the 3rd of July, 1969, it threw debris 6 miles. The Starship, with its super heavy booster, will have twice as much fuel practically in that range, in the range of twice as much fuel as the N1 or Saturn V. And the Saturn V was said to be the equivalent of a small atom bomb if it had gone off on a launch pad. So, however you want to equate it, 6 miles of flinging things, maybe further with twice the fuel. It's not trivial, to say the least. So if you live within 2 miles of that, you shouldn't be there. You shouldn't be you shouldn't be at your home. You shouldn't be there at all in the launch of one of these systems. I would not want my home there. I definitely wouldn't have my cat, my dog, especially my kids there. So these are things to consider. Elon, gosh, guy, what are you thinking? You build your big launch complex 2 miles from a small little community? I guess you were planning in advance to buy it out, but you know, they may not go along with you, and that might hold you up. And that's going to be part of the programmatic risk that you face, is that you may be held up by people that just don't want to move, and the FAA might choose to not approve your launch. So that gets into the programmatic side of your risk structure, is that you may not get launch waivers and launch licenses as fast as you were hoping for. And you were asked about this when you had your Starship program presentation a couple weeks ago, and you kind of were cavalier. Oh yeah, I've been talking to FAA and we're good buddies and friends. Yeah, I've been up to FAA and talked to AST myself. I've been up there because I was having to do that when I was doing my cat's prize launch out in the Gulf of Mexico. And the thing that saved me a lot of grief was the fact I used Eglin Air Force Base for range schedule services, but I still went and filed a launch license application, waivers and all that stuff at the AST office in Washington, D.C. at the FAA. And we spent months, maybe a year, in our system with just a little old bitty hybrid sounding rocket flying out, 200 miles out in the Gulf of Mexico, far away from anything. And our probability of casualty was negligible if we'd have flown this little thing even into a city, which I wouldn't have done. But, there was such a small booster compared to anything you're doing, Mr. Musk. So it's not a trivial matter by any measure. And a measure to consider is the speed at which the FAA might approve your launch license. And I would expect and advise you that the FAA moves at the blinding speed of government. Yes, the FAA moves at the speed of government, meaning, your schedule doesn't mean a whole lot to them necessarily. They're not in a hurry. Things go in their inbox. Look, I've worked with government for years. All my life I've been working with government. And once something goes in the inbox, they get around to it when they get around to it typically. You typically expect 6 months for those kind of things. Now, I know you've been working this stuff and you've been on top of it, and this is when you're trying to buy Boca Chica out. And Boca Chickens, if I were you, I'd say, oh, get out, take the money and run. And, you're going to get launch, you'll get opportunities to do these launches. Of course, I know a lot of you went there because that's where you want to be. That's your dream home. It's this, it's that. But, hey, there is severe risk at being 2 miles from a launch complex. Risk has two components: severity and likelihood. Elon may tell you the likelihood's extremely negligible, but the consequences are off the charts. I mean, if your home gets exploded, that's the worst thing you can imagine. If Boca Chica gets fried by the whole booster coming down on them instead of it blowing up, Well, that's it. Game over. Oh yeah, and one of the Long Marches did that to a town in China, and there's pictures of a school that was totally obliterated and such and so forth. It's happened. So it's not something to trivialize by any stretch of the imagination. And the worst, very worst programmatic risk I can imagine is if you have one of these boosters in the early launch, you got 100 people on board. Maybe the first time you put 100 people on board, that'd be the most critical launch, or your launch going around the moon with a Japanese artist. If in the early flight, especially one with a lot of people, this thing explodes on ascent with everybody watching, that could, I'm not saying well, could be a Hindenburg type moment. Greg, what's a Hindenburg type moment? Well, the Hindenburg was an airship that exploded. It was a German airship that came to the United States. It was, we would not permit the Germans to use helium because we had the helium, so they had to use hydrogen to fly it, and hydrogen burns. And they thought they had it under control. They thought they had all the safety systems, but upon trying to land in America, apparently there was you build static charge in flight, and apparently when some of these systems came in contact with the ground, something happened, something discharged or lit a spark, and the Hindenburg exploded and burned. And there was a reporter who was in full panic mode reporting it. And I think the airship industry had a lot of merit, but it was dead on arrival from that moment forward because it got fixated in the minds of the public that this is crazy, dangerous, and nobody wanted any part of it, which is sad. I would love to see big 400-foot long airships floating through the air today, but we don't because of the Hindenburg. Now, immediately there were some control issues, and the Navy did try using a few large airships for a brief time, but the Hindenburg was a key thing that limited that industry. Today we have better technology. There's systems and ideas for using airships, and they're just having a hard time coming to market. And the ghost of the Hindenburg still hangs over. But now we'll talk about the strengths of SpaceX and Elon Musk. And I will say there's two areas of strengths that make a key difference for their operations. One is flexibility. We see SpaceX changing things on the fly every time, all the time. This is much faster than the speed of government because in the government system, everybody's got their own little fiefdoms and stovepipes, and don't change my little cookie over here. I got this set up and I've invested too much in it. And they would not permit such things as throwing out the mandrel, that you put all the money into to build a carbon composite hull for your spaceship. Oh my God, you can't do that. Well, yeah, Elon Musk can. He's willing to make drastic changes if he gets drastic improvements in the systems, and he found ways to do that by using stainless. Man, that's off, Elon. But that said, it pervades the culture of SpaceX. This whole notion that if there's to try to get rid of parts, anytime you can get rid of a part or a procedure or process, boom, everything's got to justify itself. That's a good philosophy. It's not a philosophy of ownership and kingdoms and fiefdoms like we see in bureaucratic organizations. And so that's refreshing. It's the power of a corporate enterprise-driven system. That is a key strength that SpaceX has. And another key strength, and perhaps the biggest of the key strengths, is the drive and determination exhibited by Elon Musk. And we've already seen when he was initially landing a lot of his boosters back on the barge, a lot of them blew up. He kept doing it. And a lot of organizations, you get a failure, oh my God, you're embarrassed, and you got to go explain it all, and you get chewed out, and get it handed to you, and your career's over, and everybody walks home. Nobody wants to take the risk. Everybody's afraid of risk. But Elon is not so afraid of risk. And this may be the saving grace that may even make Elon Hindenburg proof in that, one, he's willing to take the risk, and two, he's funding it. And he's determined to move forward. I mean, to Elon, the BFR, Starship, Heavy are the most important things. And apparently these are being developed on a fraction of the cost of his overall development systems, according to what he tells us. And with his Starlink constellation, he may readily be able to pay for all this many times over. So that determination, the deep pockets he may be growing through Starlink and maybe other avenues, may be what insulates Elon from potential early failures. I would expect early failures in development. I mean, rockets go boom. Rockets have always gone boom, and rockets always will go boom. Given that, you got to expect just that. And if you expect just that, and Elon has faced just that, and if you're willing to live with it and move on, you might survive and thrive with your system. And it is my hope that Elon has that determination, and there's he does. But if something should happen to Elon Musk and bean counters take over the organization, it may be a completely different story, and then SpaceX might evolve into being another Boeing or Lockheed Martin or whatever, just cutting the cookie cutter stuff out and going to the government doing contracting or just using the systems they got. Well, they would already have a big leg up on anybody else because they would be starting out with the cheapest boosters. But the determination, the innovation, the things that we see coming out of SpaceX today are personality driven by Elon Musk, and to some degree, probably by Glenn Shotwell too, maybe as much by her as Elon. And some of the current leadership at SpaceX hopefully is in the same league. If the bean counters come in, forget about it. Hopefully SpaceX will make their milestones and get us way out there before that day should come. So Elon, don't ride the first booster. Listen to Allison's laws of rockets, my friend. If you really have the stream, you want to succeed, don't ride the first booster. In a real space Navy, Captain Kirk would not jump off the ship and fight every space alien directly in hand-to-hand combat like in, certain TV series we've seen. So just bear that in mind. Be patient. You'll have your day. But if you want to be the change agent that keeps this movement sustained, stay alive. So that's the hope. And I am highly encouraged by what they're doing. The fact of the matter is there is competition. It's not on the radar. We don't get to see it. But Jeff Bezos is active doing things. He's just keeping quiet. Everybody thinks Elon Musk is light years ahead of him. Maybe he is, but Bezos is still in there. He's still moving. He's not giving up. And he is the richest man in the world. And so Bezos has certain advantages too. And between the two of them, it's good to know there's competition there. And, everybody else that wants to be in the launch industry is going to have to radically change the way they operate to be in the same league and keep up with these guys. A lot of the industry are trying their best to catch up to the Falcon 9 and the Falcon Heavy, whilst Elon's already moving on to his next phase. And he'll be into his next phase before they even get to there. How well is that going to bode for them? Well, they do have certain organizational ties to government entities like the Air Force, who would like to see diversity in their portfolio of launch options. That may sustain them for a while, but wake up, guys. You better get very innovative and be willing to take risks. It's kind of hard to do with the corporate board structure and making the kind of reports you've done before. And I hope you can get some leaders in your organizations that are very much personality driven, goal driven, and willing to take risks like they've never done it before. That's what it's going to require for your organization to survive and thrive. So all that said, we've looked at some of the top level. This is just top level discussion. I'm not getting into the beans and going through and doing charts and detailed analysis. This is just a high level snapshot thumbnail picture of general risk that are faced by SpaceX and the strengths of SpaceX to move forward. Now, on the opportunity side, oh my Lord, SpaceX will be able to launch people to Mars and at costs that are, if it works like he says, if he's able to pull off the things he talked about, it will be on the order of what it was like for colonists from the old world to come to the new world in the very, very early days when they could basically mortgage everything they ever owned in their lives and come over as indentured servants. That was how they got over here initially. And we may see things comparable to that, where enough people would have the kind of resources they would need to really start space colonization efforts. That said, I would say that Mars is highly risky, and I would much prefer to see people doing the orbital space habitats along the lines outlined by Bezos. But those are also the visions of Gerard K. O'Neill, the O5 Society, the National Space Society, and people like me have been espousing for decades. So I was glad to see glad to see Jeff Bezos pick up on that. And but I'm glad to see that we have two different approaches and both being pursued, because competition and diversity are very key to the long-term goals for human settlement of space, for humanity to get all its eggs out of this single basket we call Earth. So all that said, I have been long here, but what we've looked at is realistically, at a high level, what are the risks to SpaceX? And they're very significant. The risks, the challenges, but the strengths are also very significant. And the opportunities are literally out of this world. So, and with that, it's time to launch the BFR again. Our own little Starship here. And now you've seen, once again, on Galactic Greg's reuse of we gotta have a little fun. So please do subscribe to my channel, click that notification bell to get future videos. I've done a lot of videos on the history of the space program. I'm going to do videos about just rocket engines in the future. I'll do videos about various safety topics, more videos about SpaceX, and guess what? Mr. Bezos is opening an engine factory to build engines right here in Huntsville, Alabama, to go with his vehicles, and they'll also be used on the Vulcan rocket. So it's going to be very interesting. And bear with me, stay with my channel, and I will cover this stuff in more depth with more videos as we go down the road. This is going to be a fun, interesting time. So again, subscribe, click the notification button, and my friends, I thank you very much